All right. It's a real pleasure to finally connect with you, Michael, because I think you were one of the voices that brought a lot of clarity in the first half of the year when Solana was, experiencing some of its darkest moments. It was a fairly challenging period, and I think there were lots of things being thrown around about Solana, and I thought it would be nice to, now that things have settled down, it'll be nice to hop on a quick call and catch up on what transpired, what is being built, and what can we look forward to into the future.
Yeah.
So Michael operates one of the leading validators of Solana, and I'd recommend that you do a quick intro as to what is StakeWiz and so forth.
Yeah. So yeah, my name is Michael, and I'm from a company called Laine. So we're a
Mm-hmm.
South African software development company, traditionally working in the Web2 space. And we launched a validator on Solana last year. So we've been progressively getting more involved with Web3 and primarily involved on Solana. First, we were running a validator on testnet, part of the incentivized testnet back in early 2021, and launched on mainnet at the end of August last year. So actually, it's just been a year, a few days ago. And yeah, so we run a validator on Solana, open to other networks. We believe in multi-chain future and don't really like this whole narrative of one chain must best all others and that kind of narrative. Uh, there's going to be different use cases and different products and utilities, and there's going to be different blockchains that achieve the best goals for those. We've built a product for Solana called StakeWiz, which is basically a website that tries to rank validators and provide alerts for users, for delegators. So if you're staking with a validator and they have really bad performance because they're frequently delinquent, which means they're offline, they're not voting, or because they just have a bad server or bad operation, or if they change the commission, you want to be notified. And there wasn't any solution that achieved that. And in January, we saw a few validators who raised their commissions, and some of them doing it without announcing it ahead of time. So we built StakeWiz, which basically lets you, stakewiz.com, so it lets you create alerts for any validator. So you can be notified by email, Telegram, or even in your Soulflare wallet if that validator becomes delinquent or changes their commission. And in future, we're going to add alerts for if they change their name, their logo, that kind of stuff. And that's expanded over time to now kind of be full on kind of analytics and statistics about validators and even staking. So you can actually go and you can select 2, 3, 5, 10 validators, and you can then say, okay, you've got your list of 10 validators, and you have 5 SOL, 10 SOL, 50 SOL, however much you want to stake, and you can distribute that across those 10 validators in any way you want. So you can automatically distribute it according to our scoring called the Wiz score, where we take 12 different metrics and we compute a percentage score for a validator. Or you can distribute it according to APY or equally, or do a custom distribution. And then you can stake to all of them with a single approval in your wallet. So to just make it really easy to go and say, okay, you're ready to stake, you want to, select multiple validators and do that as easily as you can.
Nice. And all of the staking is non-custodial, right?
Yeah, all staking on Solana, native staking is non-custodial. So we just plug into the native stake program, just formulate the instructions, but you're not staking with StakeWiz, you're not staking with Laine in the sense that you're giving us stake. Anytime you stake with a validator, you create a dedicated stake account, which is a separate account that the stake is transferred to, but that account is in your control. The validators never have access to it.
Mhm. Nice. Why did you pick to have such a strong focus on Solana?
Well, so my background personally in cryptocurrencies goes back to 2013 when
Hmm.
I first heard about Bitcoin and Litecoin back then.
Hmm.
And I took an interest at the time, then kind of stepped away from the space for a few years and got involved in 2016, 2017 in Bitcoin mining, and was buying, these big ASICs from China and setting up kind of a mining operation, and did that for a few months. But then the ongoing maintenance and the electricity costs and the whole big crash that happened in 2017 um, kind of drove me out of it again, and wasn't involved at all after that for a few years until late 2020, early 2021. And I kind of started to get back into the space and researching what is happening at the time, and the current layer ones that are around. I was obviously familiar with Ethereum, but
Hmm.
never enjoyed using it because of the high gas fees and the transactions aren't very fast.
Yeah.
Um, and that's when I came across Solana. So even going back to when I first learned about cryptocurrencies, I always kind of thought that for it to truly be usable on an everyday basis, you need to have
Yeah.
almost instant settlement. That's the major drawback with Bitcoin, with Ethereum, is that it takes too long to settle and it's too expensive. There's
Yeah.
no point paying for a coffee for $4 with Bitcoin or with Ethereum if it's costing you just as much just to sign the transaction. So when I came across Solana, it appeared to achieve all of these goals that I thought a blockchain should achieve. Often referred to as the trilemma, and that really got me interested. And then kind of digging into it and seeing the community and the dev team and how the core engineers communicate on Discord and their approach to everything, just gave me a lot of confidence in what is being built.
Nice. I do want to touch on your thoughts on the layer twos, but I think we will get to that in the competitors segment later on. So it's nice to see what your journey was like into crypto. And I think what drew you to Solana was really the performance and the people that you were working with and collaborating with. Um, so let's dive into the network congestion in Solana. And if you could go back to that time and, maybe help encapsulate um, what some of the high level event incidents that occurred, what caused it, and what was it like having to deal with. I think you were the one of the few people who were transparently communicating exactly what was happening in almost real time, and I think that really helped bring together the community for Solana. And, that's also part of the reason why I really wanted to have you on this episode. So, yeah.
Yeah, so if we look at the history, so Solana mainnet launched in, I think it was April 2020. So I wasn't involved at the time. And if you look at the history of mainnet or mainnet beta, there have been four? Yeah, I think four network outages um, in December 2020, September 2021, and then April and June of this year. And if we look at, so it's important to note that the cause of each of those outages has been for different reasons. So it's not that it's one fundamental issue that is reoccurring. It's growing pains as the network grows and scales. There are new issues that come to the fore. And the first one I was around for was September last year. It was 2-3 weeks after we launched our mainnet validator. And that was congestion and bot spam, and it was kind of leading to validators struggling to come to consensus. And then what they have to do is maintain a record of basically concurrent forks as those forks are growing longer and longer, because one group of validators says this fork A is correct, and another group of validators says fork B is correct, and they keep adding blocks to it, and the forks get longer, and you have to maintain the whole history of who is voting on each fork and which transactions are in them. And it basically causes your RAM to explode. And what happened was that a bunch of validators just kind of ran out of memory and crashed. And as soon as you lose 33% of the stake, you no longer have enough validators available to form a block, to agree on a block. And that the source of that was basically just congestion and just a massive amount of spam. And what happened in September, and this was related to NFTs and Candy Machine mostly, but what happened in September 2021 last year was that because of all these spam transactions, there were actually not enough vote transactions being included in the blocks. So that was fixed at the time by basically creating a priority mode where validators would prioritize prioritize votes over other transactions. So validators actually have like a fail-safe mode since then, where they go into kind of a vote-only mode when the forks get too long and they're unable to confirm blocks, where they basically ignore all non-vote transactions and they just focus on maintaining consensus. So that was the first outage that I was around for that I can speak to. And, that was addressed through this vote-only mode, which got us through a couple rough months quite well. If we look at November, December, January last year and early this year, we had quite a kind of NFT bull run, a lot of activity, and we had lots of periods of congestion. And this kind of fix from the outage in September really prevented the network going down. And then in more recent memory is obviously the issue in April, and then the one in June. And those are very different from each other. The April issue was a little bit similar to what happened in September last year. It was also related to the spam, but it was a bit different because it was kind of weird. We were seeing these massive spikes in network traffic. So it was someone had written a NFT bot that was hitting validators with up to 4 million packets per second. So we saw validators that were experiencing over 50 Gbps in inbound network traffic. Now, most validators only have a 1 Gbps uplink. The big validators usually have 10 or even 25, because the more stake you have, the more traffic you experience. But most validators, probably over 80%, have a 1 Gbps network. So basically their links were just getting completely saturated. And then you can't even prioritize votes because there's just nothing that can get through because your pipe is just blocked. So, which led to kind of the same situation with, fork selection, and then basically validators that don't have enough memory, enough RAM, they run out first. And, if you're not configured properly, so even if you don't have enough RAM, if you configure your validator correctly, you can minimize the impact of this. But some validators just didn't have the capacity and they ran out of RAM, and then they crashed, and then it leads to that same situation. So you run out of enough stake and you can't confirm a block, and the network kind of halts. And then that was kind of quite bad, and that's what led to the whole conversation around Quick. Well, Quick was already being discussed before then, but this really solidified the need for Quick, which is a new network protocol that's now being rolled out. And I think we'll talk about that a little later.
Yeah.
But yeah, that's kind of a pivotal moment that confirmed the need for it. And then the final halt, which was in June, was a completely unrelated issue, which was actually just a bug relating to something called a nonce. So a nonce is a a special type of account that allows you to sign a transaction at one point in time and submit it at a different point in time. So generally, when you sign a transaction on Solana, you need to include a recent block hash, which basically means you have about 2 minutes to submit the transaction and for it to be included in a block. Otherwise, it expires. But using a nonce, you can get around that expiry time. And this is usually used by institutional kind of investors, setups that have a very cold wallet. So you have to sign something on one machine, transfer that transaction, and then submit it from a different machine. And those types of things, you want to have enough time to do that. So there was a bug relating to nuances, which was basically allowing the transaction to be submitted twice. And then some validators didn't realize it had been submitted a second time, and some did. So then they disagreed basically on whether this transaction was legitimate, and that led to kind of a standoff, and the validators kind of stopped at that block. And that bug was obviously fixed at the time. And that's kind of where we are now. And it's important to, I think, mention that the reason that Solana halts is because we have this proof of stake system where you need to have consensus, and consensus can fail. And halting doesn't mean that someone is pressing a button to stop the blockchain. That's not possible, and there's no central entity, no developers that can, just press a button and it stops the blockchain. Halting is basically a situation where validators fail to agree on the last valid block. So then the change is just stopped at whatever is the last confirmed block, and then you have to, obviously identify what the issue is and then restart from that point. And this can't happen on a proof of work blockchain. That's why on Ethereum and Bitcoin, you don't have this type of outage. But there have been times where Bitcoin hasn't produced a block for multiple hours, and that's just because, with proof of work, it's kind of a lottery who gets to produce the block. But once you've produced a valid block, no one gets to disagree with it. Hence why you don't have this consensus-related liveness failure. But yeah, so I think that's important to note, and that's an important difference with kind of consensus-based protocols.
Yeah, I think that's a distinction where liveness failure, if you look at it from a perspective of proof of work or proof of stake, they happen in different contexts. So, the people who say it never happens in proof of work, that's not technically true, right?
Well, it depends. I would say it is. It's technically it depends how you define it, right? Because in theory, Bitcoin is in a state of perpetual liveness failure because you never know if there's going to be another block. There's never a guarantee that someone is going to mine the next block. There's a statistical probability that it will be mined within 10 minutes. But there's a very small statistical chance that it'll take a day. Right. So in a way that could be seen as a liveness failure, but it's very different in its nature.
All right. I'm still debating if we should. I guess it's probably better to dive into the solutions, because then you can touch upon, why Solana didn't have a mempool in the beginning and what has emerged with Quick and so forth. Yeah.
So it's interesting to try and visualize how Solana actually works. As a validator, when we look at what's happening on our validator machines and getting to know the code and how the whole protocol works, it's really a technological marvel. The speed with which the whole network, now we're talking about 2,000 validators and I think about 3,000 RPC nodes now, which are essentially validators. They're not voting, but they're receiving and validating every transaction. So you got something like 5,000 nodes around the world in who knows how many countries that are in real time synchronizing thousands of transactions per second and validating those transactions, confirming the signatures, executing the transactions and the programs that they call upon, on-chain programs, in many cases compiling those on-chain programs in real time as well, using the just-in-time compiler. And every 4 blocks, every 4 slots, the leader, which is the validator that's producing the block, changes. So which is about 2 seconds. So every 2 seconds, you've got this kind of swarm of 5,000 validators and RPC nodes around the world that every 2 seconds basically has this like a fire hose of transactions, and every 2 seconds it gets directed to a different leader, and that leader is catching all that water out of that fire hose or those transactions, packing it into a block, and then streaming it out in parallel to hundreds of validators, which then distribute it further, kind of fans out. And all of this is happening continuously in real time. It's an insane volume of information, of data that is being synchronized. And then,
Amazing.
and then once in a while, unfortunately, someone trips up, someone slips, and then kind of the whole orchestra comes cascading down. And so from that side, I think I'm a little forgiving of these network cults, because it's in some ways actually remarkably resilient when we look at how few halts there have been, considering how complex, and especially if we look at the major changes that are being introduced with constant version upgrades. We're seeing, at one point we were seeing a new version being released every week almost between April and June. Now we're down to about 2 or 3 a month. And those are major changes that are constantly being introduced into this, rapid system, and multiple validators that are running on different versions as well. But yeah, in terms of solutions, so the main issue obviously has been bots and spamming relating to NFT mints. And essentially what was happening is that you've got an NFT mint that's open to the public, and whoever submits a transaction first gets the NFT. So what happened is, and arbitrage is another area where bots are also prevalent and an issue. So basically the bots are trying to be the first transaction to mint the NFT. And they figure that if they submit thousands or millions of transactions, they can A, improve their chance of being first, and B, drown out the competition. But for validators, this is obviously causing a lot of issues. So there have been a ton of improvements with the current network protocol, the current system. So currently, Solana uses UDP, and I'm not going to get into too much technical detail of how that works, what that means. But essentially, there's been a lot of optimizations to allow validators to handle more incoming duplicate transactions. So just streamlining the pipeline of how do you filter out the duplicates, verify the signatures, and then process the transactions. Now, with Quick, which is kind of the next step, we'll be able to actually know who is sending the transaction. So with UDP, you don't know who is sending it. You can't verify it. So with Quick, we can. And then what we can do is we can actually say, okay, we want to give some amount of priority to staked senders, meaning validators that are submitting transactions or sending transactions to each other
I
have a
see.
priority. Yeah. So now, in future that we'll say that, okay, a staked sender relative to their stake will have some amount of priority. So for instance, 50% of block space is reserved for staked senders. And I don't know what the final numbers are, but I think it's something in that range. And then basically, if your validator has 1% of the total stake, you get a guaranteed access to 1% of that 50% of block space. So it's relative to stake weight. And that will already kind of ensure some level of quality control. And then the
Yeah.
next one is that unstaked senders which are basically, any RPC node, or you can run a TPU client yourself. You don't need to have a node to be able to submit transactions directly to the leader. An unstaked sender has access to the remaining block space, but now using Quick, they use what's called a Quick stream. And in that stream, you authenticate who the sender is. So you have a handshake, so you know what IP they're sending from. And then you can implement kind of flow control. So what happens is they're allowed to send a certain amount of transactions per second. Once they reach that threshold, the Quick protocol, has built-in mechanisms to kind of throttle that sender. And if they exceed a certain amount for too long of a period, you can just close that stream altogether and actually block them. So Quick basically gives us a ton of tools and utilities to manage this communication between nodes and between validators in a way that we can then shape the traffic to filter out the spam. And the
Almost
goal is
like a
not
traffic
to
control.
Yes, yeah. The goal is not to censor anything like that. Part of the thinking is, so because staked validators have priority. So now remember, we have 2,000 staked validators around the world. At any point in time for any block, one validator is the leader. So the goal is that if you want to submit a transaction, your transaction needs to get to that validator. Now the thinking is that instead of submitting the transaction to that validator, it would make sense to submit it to a different validator first. Let that validator, do the deduplication, signature verification, and then forward it to the leader. So the leader is only getting kind of pre-cleaned transactions, which will obviously reduce the workload on them by quite a lot. And that I think is maybe down the line something that's being considered. It's not something being implemented now, but because you have that guaranteed block space for staked senders, by first submitting to another validator, you can basically be assured that your transaction will be included.
And that is just for Quick, right?
Yeah, that's all using Quick.
Okay.
So basically, if you as a regular user, or your DApp, or whatever, an RPC node, you've got a transaction you want to submit, and you submit it directly to the leader, you are now in that unstaked group, and which means you don't have a guarantee that you're going to be included in the next block. So you actually have an incentive to now go to a different validator who isn't the leader, give them your transaction first, let them process and forward it, and then you get part of their allocation of guaranteed block space.
And how far along has Quick been rolled out?
It's being tested on testnet.
Mm-hmm.
So the rollout for Quick involves kind of 3 components. So the first step is that validators need to be able to receive Quick transactions. So that's the Quick server. So that's actually live on mainnet already. So all mainnet validators are currently running Quick servers and are capable of receiving Quick transactions. The next step is sending via Quick. So that's the Quick client. So that means validators sending via Quick and RPC nodes sending via Quick. On testnet, all validators and RPC nodes are using Quick. On mainnet, a lot of RPC nodes are using Quick already. So on mainnet currently, we're already seeing a situation where a good percentage of transactions are being sent and received via Quick. And then the third step would be disabling UDP. So basically disabling the old network protocol. So at the moment where we are is there's obviously testnet being tested fully with Quick. Mainnet is kind of 50-50 on Quick. So as the next step, we'll probably see mainnet validators enabling sending via Quick. And then at some future, yet to be determined point, UDP would be disabled.
So maybe it even happens before the merge.
I don't know. I'm not sure if that's. I mean,
No, I know.
yeah,
It's just
I
a
don't know if
pun.
it matters really, but no. It might happen that validators start sending via quick, absolutely. But UDP being disabled, I think we're at least a month away, maybe more. Yeah, because so the thing is, validators have 3 ports on which they communicate with each other. So there's the TPU, the transaction processing unit, and this is the primary port that regular transactions are submitted to. So when you submit a transaction to a validator or to an RPC node, or not an RPC node, because you use RPC for that, but to a validator, you would submit it to the TPU port. And that is the primary port that is being changed to use Quick. But there are 2 other ports, which are TPU forward, which is for forwarded transactions. So you submit a transaction to validator A. Validator A is not the leader. Validator B is the leader. What will happen is validator A will forward your transaction to validator B. So your transaction to validator A arrived on the TPU port, but is now being sent to validator B on validator B's TPU forward port, which is a different port. And then the third port is the TPU vote port. So the votes actually have their completely own port and network path. And those 2, as far as I'm aware, are still on UDP and not even tested to use Quick.
I see.
So that'll be a bit of a blocker for completely disabling UDP.
And what about okay, so quality of service that already is part of the description of staking that you stake weighted that you mentioned for Quick, right?
Yeah, stake weighted quality of service is exactly that. So basically, you can prioritize transactions based on the
And what
relative
about the
stake weight
fee
of the sender.
markets? Mm-hmm.
Yeah, that's another very interesting innovation. So it's something that's also being developed, and it's also a major solution to some of the issues we've been having, but it's also completely unrelated to Quick. So fee markets and Quick don't really depend on each other or have nothing to do with each other. What fee markets do is, at the moment, pretty much all the time, I'm just thinking now, yeah, basically every Solana transaction has a somewhat static fee. So at the moment you're paying 5,000 lamp ports, and there's a billion lamp ports in a sol. So you're paying 5,000 lamp ports, which is 0.0000 something 5 sol per signature on a transaction. So your fee depends on how many signatures you have. So, a regular transfer, if I'm just sending 1 sol to someone, is 1 signature. But when you're dealing with staking, you might have 2 signatures. That DeFi might have 3 or 4. So, but generally your fee is a multiple of 5,000 lamp ports, and there's no dynamic component to it, unlike with Ethereum. But now what is being introduced is hotspot fee markets. So what this means is that if when you write to an account, so if you're changing the balance or the content of an account, for instance, a token account or your main SOL account or a contract, then you need to lock that account, because you can't, Solana validators execute transactions in parallel. So a validator could be executing 10 transactions at the same time. But those 10 transactions can't be accessing the same account, because that's how you might end up with double spending. So basically at the moment, if you have a lot of transactions that are interacting with Candy Machine, which every NFT mint or most NFT mints do, what happens is those transactions cannot be parallelized. So they have to be run one after the other. So that's a hotspot. So basically what's being introduced with the hotspot fee markets is that when you have a lot of transactions that are trying to access the same account, then the fees just for those transactions are going to increase. So if you have in one block 5,000 transactions in total, and 3,000 are votes, so those are fine, those are the standard fee, ignore those. You have 2,000 remaining non-vote transactions. 1,000 of those transactions are NFT mints, candy machine mints, and 1,000 are regular transfers. Those 1,000 regular transfer transactions will just pay the normal fee, but the 1,000 NFT mint transactions will have to pay a higher fee because of that congestion. So it's a very smart way of solving this, where congestion will only penalize or affect the users of the congested resource and not the entire blockchain.
Yeah, very interesting design. I think I saw another podcast where Anatoly was saying that if these outages or incidents didn't occur, they wouldn't have been able to develop these solutions or sort of anticipate it.
Yeah, I think it's definitely a great kind of push to optimize stuff that otherwise might be ignored. If we think back, every blockchain has had its ups and downs. And in the early days, Ethereum had a bunch of performance issues and problems with the forking and that kind of stuff. And it takes time to find a solution that kind of addresses all these problems. And probably there's never going to be an ideal solution. It's going to always be ongoing improvement and development. So without the outages, what Solana looks like today might be a lot different and might be a lot worse.
I think that encapsulates the upgrades that are coming to Solana and what we can expect. Let's dive a little bit into some of the things that creep up on crypto Twitter once in a while about Solana. I think even today there was someone making a claim that the migration of DYDX to Cosmos is a sign that people prefer less security and less decentralization. I think I saw you chiming in and asking, how is this even true? What are the facts here? And so I think, what are your thoughts around Solana's decentralization, security, and, because if say you would determine in terms of the Nakamoto coefficient, those numbers are very healthy, right? But where do you stand in all of this?
Mm-hmm. Yeah, so it's a tricky topic, and Anatoly actually tweeted a few days ago saying that decentralization is not a range, it's an absolute. And I kind of disagree with that. I think that it absolutely is a range. And I'm not saying that Solana is necessarily more decentralized or the most decentralized than other blockchains. But you frequently see these claims on social media that claim that Solana is less secure, less decentralized. And often they are based on a lack of understanding of all of the facts, which is why I replied and asked, on what basis? Because I don't know that person's background or knowledge or how much they understand. It's very difficult to compare different blockchains as well, because the concepts aren't always the same. A validator on Solana plays a very different role than a validator on Ethereum. They're not the same at all. So comparing the numbers of validators is actually meaningless because they don't do the same thing. So with Solana, obviously, it's keep in mind the blockchain is less than 2.5 years old. So keeping that in mind, I think the network does a pretty good job of decentralization, but there's also still a lot to improve. The Nakamoto coefficient is something that is often used to measure decentralization, but it's not the only measure of decentralization. It's not or depending on how you apply it. So, generally with proof of stake systems, we look at what percentage of stake is needed to create a liveness failure, to basically prevent finalization of a transaction. And with Solana, it's 33%, because you need 66.6 to confirm a block. So the Nakamoto coefficient represents how many validators at least do you need to control 33.33% of stake. And right now that number is 32. So that's one way of measuring it. But another way of looking at it is, and I think Nakamoto coefficient is, in general, is a good idea, but you can apply it differently. So we look at, okay, how many validators control 33.3% of stake? But another way of looking at it might be how many wallets control 33.3% of stake, or how many VCs. Because, frequent criticism is that Solana, is what they call a VC chain. But the truth is that in the last 5 years, most new blockchains have started with VC funding. And it's not necessarily a bad thing. The question becomes, what are the VC's intentions, and how are they going to exit, and how damaging is that going to be to the ecosystem? So with Solana, I think there's a lot of FUD that's gone around about token distribution, and a lot of that is based on some outdated graphics from this company Messari. And there's actually an article, a research page by Binance, which has the most accurate data. Was the Messari article, and the Messari data is not based on the full supply. There were about eight or nine, I think, different initial token sales over a period of 6 or 8 months. And the Messari article was, when the total supply was like 20 million SOL, and now it's over 500 million. So the distribution has changed a lot. Not to say that it's completely decentralized, because you can't. You have to think about, start out with 500 million SOL. Who do you give it to, right? So you got a bunch of VCs coming in. They give you $100 million or whatever it is. They're taking on a lot of risk by giving you the money. So then obviously they want something in return for that. You can't just give out 500 million SOL to a bunch of people on Twitter. It's not going to be sustainable, and it's not a good way of dilute. Like, it's just going to crash the token, right? So you need some kind of controlled emission. And in total, VCs have a decent amount of the total supply, but not as high as some of the the stuff on Twitter suggests, because there were also sales for validators. Those are not VCs. Early validators that were part of the launch of mainnet were able to buy SOL in one of the initial sales, and it's not fair to lump them in with VCs. Those are independent infrastructure providers. You've got a CoinList auction and a bunch of other stuff like that, and then obviously the core engineers who are committing years of their life to building this, and then the Solana Foundation has a big bag, which is basically being used to stake validators. So you've got 1,500 validators that receive stake from the foundation, and are making money out of that. So in that sense, I think Solana does pretty well in terms of decentralization. Definitely, the chain is decentralized in the sense that the chain is operated by validators, and no single person, or not even a group of 5 or 10 entities, can control the chain or control the validators. So when we have a restart, we need 80% of stake to restart the chain. That's at least 800 validators that need to participate to achieve that number. Like, that's the minimum. That's kind of the inverse Nakamoto coefficient. And even halting the chain. And if you see some of the discussions that happen on GitHub, on Discord, on Reddit, on Twitter, validators don't just step back and do what Anatoly tells them to do. There's a lot of discussion and debate and disagreement. And hopefully with time, what I would like to see is more governance in terms of on-chain governance. So we're seeing it right now. There's a proposal that's being run on testnet to raise the minimum stake account size to 1 SOL. And validators get to vote on that relative to their stake weight, for instance. So yeah, I think we're moving in the right direction for sure.
There was another debate I think that I saw Anatoly get caught up in, and again, I know this is your own view, but the certain groups like to focus on home validation in this day and age. I don't know. My premise is like, what is the use of the protocol? Then perhaps we can understand the importance of home validation. How do you see this unfolding with regards to home validation?
Yeah, I ran Bitcoin miners back in the day. So I think we really need to, it is a trade-off. You need to look at what you want to achieve. Realistically, with home validation, you're going to struggle to, you're not going to be able to achieve the performance that Solana seeks to achieve. So then the question is really, is decentralization defined as anyone being able to run a node? Or is decentralization defined as there being a sufficiently large number of operators and nodes around the globe and in different jurisdictions so that no single entity or government or group could impede or censor or halt the chain? So, and what is so if we look at kind of the original kind of ideas behind crypto and decentralization, the goal was to prevent censorship, right? And halting. So you don't need home validation to achieve that necessarily. So I think home validation is nice if you want a long-term store of value like Bitcoin. If you just want to have it sit there and be safe and not transact with it. But if you're talking about something that competes with something like Visa, where you have rapid, almost instant confirmations and transaction processing, you're going to need a higher level of hardware. And even if we look at Ethereum, Ethereum uses mostly cloud-based nodes for their validators for proof of stake. You can run it at home, but with slashing, there's a risk. So realistically, if I run an Ethereum validator, why would I run it at home, where a hardware failure, a power outage, an internet failure, all of that could lead to slashing, when I could run it on a VPS that I pay $5 a month for?
Points that always get lost, right, on social media, like the reality of what it is to run something versus the claims that they make.
I mean, in the end, the question is, can the US government, can Anatoly, can Jump Crypto or FTX or Alameda, can any of those people shut down Solana? And the answer is no. And as long as that answer is no, then I would argue that it's decentralized enough. And the same goes for other blockchains, Ethereum, Avalanche, and all of them. So yeah. And I mean, that's where I've written a few threads on Twitter recently. I have some, I think, legitimate concerns around Ethereum's proof of stake system, for instance. And I don't hate Ethereum. I don't want it to fail. I own some ETH myself. So, and obviously it's the original smart contract platform. It's brought amazing innovation to the space, and been the inspiration to probably most new L1s that exist. So it's not something that, I'm saying because I wanted to fail. But if we kind of objectively step back and look at the statistics, the same as we do for Solana or for Avalanche or for any other blockchain, the truth is that Ethereum, so when we talk about liveness failure, or sorry, not liveness failure, but if we talk about censorship, on Ethereum, you would need 51% of validators, or 50% plus one of validators, to prevent a transaction or a block from being included in the chain. This was a number I've been struggling to actually find, in the documentation, or find what the actual number would be, the threshold. And there was a Ethereum engineers call 2 weeks ago, and Vitalik actually mentioned this number. So that's where I'm getting it from. And I referenced that video in a tweet recently. So you need 51% of validators, or 50 plus one, to basically censor a transaction. And this is obviously relevant in terms of Tornado Cash and all this recent controversy. So now the issue is that, like I mentioned earlier, validators on Ethereum are not equivalent to validators on Solana, because an Ethereum validator always represents a fixed amount of stake, 32 ETH, whereas a Solana validator represents anything from 1 SOL to 5 million SOL. So that's already an important distinction. But the other thing is that validators on Ethereum don't maintain the full state of the chain. They depend on full nodes to do that. There's about 6,000 full nodes on the Beacon chain at the moment. So, and if you look at validators, the distribution of validators, about, I think, 4 entities control 50%.
Yeah.
So, which means that, Lido is obviously the biggest with, I think, 32% at the moment. And Lido, I think, is it's a DAO, but the company behind it is registered in, I think, the Cayman Islands or something. If you look at like the website and who, the terms and conditions and who runs that website and stuff. So I don't know how subject they would be to US sanctions, for instance. But if they were, and they might be, I don't know. But if they were, Lido and Binance is another big one. Kraken, but I think Kraken is UK based. Coinbase, those are US companies. So you're now looking at a situation where we could realistically argue that over 50% of Ethereum validators are subject to US jurisdiction, which is not a great place to be in. And it doesn't have to be that way. Obviously, it will change with time, and we might see an explosion in the number of validators once we have a merge, because people might still be hesitant to stake at the moment, and especially once withdrawals are enabled. And we might also see an outflow of validators once people are able to withdraw. So the landscape is probably going to change a lot. But all of this is to say that there are issues and concerns on all of the blockchains. None of them is perfect. And I think this kind of echo chamber that we find ourselves on social media in is not helpful, where everyone in Solana is like, oh, Solana's the best, Ethereum sucks. Everyone on Ethereum says the same in reverse. The reality is that we probably all want kind of the same thing, and we don't need the other chain to fail for our chain to succeed. If you believe that, then your chain, you've got some kind of insecurity about your chain's underlying fundamental technology. So the reason I believe in Solana is because of its technology and what it achieves. And I'm not worried about Aptos or Sui or Avalanche or Polygon or anything else, because I don't think they can achieve the same results that a Solana achieves, which is the fundamental reason that I got involved with Solana.
Yeah, I think, like you mentioned, perhaps the environment might also change, because I think there's something like Rocket Pool emerging, where they claim it would be more decentralized than, say, Lido, for instance. Okay.
Well, Rocket Pool has been around for a few years. The thing with Rocket Pool, I think you need to stake 16 ETH instead of 32. But their token that you get for staking isn't as liquid or something like that, which is why it wasn't as popular. And they're now changing it so you can actually stake 4 ETH. So that should actually make it a lot more popular. But ultimately, it's still a pool, right? And with the pools, if you look at Lido, it's not one operator that's controlling all of the validators. But it is one smart contract that controls all the validators. So it's not as bad as one operator controlling them, but it's not as good as 13 completely independent operators either. It's somewhere in the middle.
So there are, again, these risk nuances that always get lost. But, that's really the main reason why I'm doing this episode, is to, try to address some of these points that have been laid out. And yeah. Okay.
Yeah, in the end, I don't think you can compare.
Yeah.
It's not apples for apples. So it's impossible to say that Ethereum is more decentralized than Solana. It's impossible to say that Solana is more decentralized than Ethereum. There are some cases where there's clear centralization, maybe like a BSC, that kind of stuff, because of just the nature of how it works. But there are so many factors that feed into it, and factors that are unique to each chain, so you don't have a comparison. And just in the end, I think my opinion has always been that what matters is it decentralized enough?
Yes.
Not is it the most decentralized? Is it decentralized enough to prevent a nation state, a single group, a single entity, a single VC from influencing transaction inclusion, censorship, liveness, any of those things?
Okay. Let's hop on to the next topic, which is about financial sustainability. I think there was also some claims about how validators don't earn that much fees from Solana. Where do you stand with this? What are your thoughts?
Well, it is true if you look at purely the transaction fees, but that ignores commission, which is the much, much larger revenue source. So Solana is currently inflationary, which means similar to Bitcoin or Ethereum. So which means that basically new SOL is created every epoch, which is every 2 or 3 days. And this is paid out to stakers as staking rewards. And validators receive a commission from that. And at the moment, so validators have 2 sources of income. They have the commission, which is a percentage of staking rewards. And the staking rewards are paid based on their participation in consensus. So based on them voting on blocks. And then the other source is transaction fees or block rewards. And those basically come from producing a block. So when you produce a block and it has 1,000 transactions, a validator will receive 50% of all of the transaction fees of those transactions. The other 50% is burned. And the economic model, I think, is very comparable to Bitcoin. So if you look at Bitcoin, you started out with a block reward of, I think, 100 Bitcoin, or was it 50? And it keeps halving, right? So now we're down to 6.25 or something. And the whole idea is that it will take many, many years for that block reward to go down and reduce and become less and less. But in the time that that happens, more and more people are going to start using Bitcoin, and the amount of transaction fees are going to increase. And essentially, eventually, they cross over and they kind of offset each other. And the same idea with Solana. So we start out with 8% inflation. Eventually, inflation will reach a terminal rate of 1.5%. That'll take about 10 years to happen. So now it's at 6.1 or 6.2%. And eventually, inflation. So inflation is going down. Staking rewards will reduce. So eventually, some people will stop staking. Staking rewards are calculated over the total supply. So if fewer people are staking, the relative rewards for the remainder will increase again. So there's always going to be an equilibrium where enough people will stake. At the same time, more and more people are using Solana. Now we have hotspot fees, for instance, a priority fee that people can pay. So transaction fees and block rewards will increase. Already, if we compare it to last year, October, if I look at the block rewards now, they're about 3 to 4 times as much as they were a year ago. So we're definitely seeing an increase in the block rewards. And at the moment, I would say that block rewards are equivalent to about 1% of commission. So validators produce blocks that are an amount of blocks relative to their stake. So the more stake you have, the more blocks you get to produce. And essentially the block rewards, if you were to charge 1% commission, that would be equivalent to the amount you're earning from block rewards.
Yeah.
Very roughly. That's the kind of guideline I work with.
And the idea is that adoption will grow. Yep.
Mm-hmm.
Yeah.
And in the end, it's always an equilibrium, right? So if there are too many validators and things get diluted too much, then eventually some validators will say it's not worth it anymore. They'll leave. Same with the staking rewards. Staking rewards go down. Some people will stop staking. So the remainder will get higher rewards. So it's a free market, and ultimately equilibrium will always be found.
All right. And let's quickly touch on the competitors. I think Solana has done a really good job with, again, this is my view, like, we put a stake in the NFT space, and I think that's helped build a lot of culture, I think, from a qualitative perspective. But I think it's not really been captured in some of the newer chains. So I just wanted to get your thoughts on what are you even looking at any of the competitors, existing ones or future ones? Or
I haven't looked in depth at Avalanche or Polygon or any of those chains.
Okay.
I have taken a look at Aptos, and we're actually participating. We're running a node on their incentivized testnet now. I think they're also doing some interesting stuff, and they have some interesting innovations. I'm not completely sure if they can achieve the same kind of performance and adoption that Solana has, but they seem to have the same kind of footing and goal in mind. So I think they definitely have some interesting stuff. But essentially, blockchains that work on everyday adoption and fast transactions and really rich development environments, those are the ones that are going to win.
And what sort of use cases do you see, with Aptos, and how might they be different with Solana? Or
I think they're going to be very similar, to be honest. They have some differences in how they produce blocks, and they have a mempool, and they obviously use the Move language for the smart contracts. But broadly speaking, I think they're very similar. Obviously, they haven't even launched mainnet yet, so they're probably about 2 or 3 years behind in that whole life cycle. So it'll be interesting to see what they develop and what direction they go. I think it's a bit too early to really to tell, and a lot of stuff will still be changing.
On the layer 2s for Ethereum?
Not really. I don't really see the point. If you can't build a layer 1 that works, it's not an ideal solution. You're introducing so much friction for users to jump between all of these layer twos. So either you have one that does everything, and then why do you need any other ones? Or you just build a layer one that works. But if you continue to have $100 gas fees on the layer one, and you need to go through that layer one every time to bridge between the layer twos,
so again,
it doesn't really solve anything.
Representing the exact user experiences in a lot of the stuff you see, you actually have to bridge in, bridge out, and it's quite costly.
Yeah, it's a solution to a problem that shouldn't have existed to begin with.
All right, and I think we're almost coming to the end of our episode. I just want to end on something positive, like what are you looking forward to with Solana? I know, yeah.
I think the phone is going to be really exciting. I'm going to be going to Breakpoint in November, so I'm really excited to see what's going to be happening around Solana Mobile by then, because developer devices are supposed to start shipping in October. So I'm hoping that we'll start seeing some cool news and innovations by that point, which will be really cool. Some great announcements. Yeah, and from a technical side, Jump Crypto is building a new client for Solana, which is great. That's always one of the criticisms, is that we only have one validator client. So having FireDancer come in and be a second client is going to be really great, just for kind of longevity and resilience for the blockchain.
Awesome. So if anyone wants to reach you, the best way is to catch you on Twitter, right?
Twitter, they can join our Discord server as well.